All right, this is a reboot of the videos on part 1.2, part 1 and 2. And so I'm going to rerun through these with audio. And the first thing we need to talk about in part 1, we talked about exponents, and in part 2, we talked about radicals. So you're watching this probably after we've already had class. And just to repeat some things, if we have 5 a's here, then that's understood to be a to the 5th if we write it in exponential form. -4 is -4 to the 3rd. 2x is 2x to the 4th. Pretty simple stuff. Exponential notation, just to review, we read this as a to the nth power, which means a is multiplied by itself n times, which are called factors. This is the base, this is the exponent. We went through a variety of properties, okay? And I'm pretty sure we went through these quite well in class, but the first property, a to the m times a to the n, if you have like bases and you're multiplying, then all we do is add the exponents, okay? So on the first one then, 3 squared times 3 to the 4th is just 3 to the 2 plus 4, which is 3 to the 6. On the second one, when we divide, we subtract, so that we end up with a to the m minus n. So x to the 7th over x to the 4th is just 7 minus 4, which is x cubed. And as I said in class, I like to simply move the exponent that's smaller up, and that changes the size or the sign. So instead of 4, it's -4, and we just add. So that way we're always adding, even negatives. Number 3 is anytime we have a negative exponent, like we said, if we move it across the fraction bar, it becomes positive. So y to the -4th is really 1 over y to the 4th. Anything to the 0 power is 1. If we have a times b, a product to a power, we can simply split it up into a product of the base and each power. So for example, 5x quantity cubed is really 5 cubed times x cubed. And whenever we raise a power to a power, in this case, then y to cube to the -4 is y to the -12th. But if you'll recall, in class we said we can never have a negative exponent in an answer. So we move it down. Now there are some other properties that we really need to focus here. And number 7, a over b to the m is really a to the m over b to the m. So 2 over x quantity cubed is 2 cubed over x cubed, which is 8 over x cubed. ab to the -n, we could flip it and make it b over a to the n. I suggest you not do that. If you recall in class, we talked about this, that I think the better way, for me anyway, is to just take 3 to the -2 over 4 to the -2. And then we can decipher that as 4 squared over 3 squared by simply flipping them to make them positive. And I think we had an example of that, why that was easier a little later on. And on 9, there you go, you just flip them to make it positive. So we also talked about recognizing when you're taking the opposite of a number and when you're actually taking a number that's being opposite to a certain power. So these two are not the same thing, obviously. The first is the -2, the quantity -2 to the 4th, and the second one is the opposite of 2 to the 4th. So that negative sign is not attached to the 2. It is attached to 2 to the 4th. So it's opposite of 2 to the 4th. And then we did some examples, and we did these in class, if you'll recall. So on the first one, all we do is simply rewrite it and then take the exponent and multiply it on out. So therefore we would have 2 times a cubed b squared would be the same, but 3 cubed was 27, and then we can combine the exponents. 27 times 2 is 54, a cubed and a cubed is a to the 6th, and that would be b to the 14th. On b, we could see that that's 1. Anything to the 0 power is 1, so that's simply 3a. C, we went ahead and took the, I apologize, I'm doing this without a pen. My pen is not working currently. So this would be x cubed over y cubed times y to the 8th, x to the 4th over z to the 4th, which then would simply be x to the 7th, y to the 8th over y cubed times z to the 4th, and then we have to go a little farther, and this is where I said we could move up. We could move up from crossing the fraction bar now, and we can change the signs. So that 3 becomes negative, so 8 minus 3 is 5. And this keeps us keeps it easy for us, knowing that the bigger exponent is always going to be positive. So that's why we move the smaller one across the sign to negate that exponent. Okay, I believe we had 2 on this one. So that simply was 6 over 2 was 3. We're going to move s to the negative 2 up. So that makes s cubed. And then our t's would cancel, so it was just 3s cubed. And then on e, it was y to the negative 2, 3 to the negative 2, z to the negative 4. And now we can go ahead and flip everything and make it positive. Oops, and there we go. And then we simplify that. Okay, so that was part 1.